Hello and welcome to another episode of Drof Dev. I should really get a opening catchphrase. So it's been a little while since my last vlog, so to speak. There's kind of one of the things at my university runs a kind of playtesting party sort of thing, and we wanted to get something up for that, similar to how we wanted to get something up for the Game On Symposium. And for those that aren't local, it's just basically like we got in a bunch of room with a bunch of other developers and tested each other's games, and it was great. So the main thing that I want to talk about today, that's easy to show. Well, I did two things. The first I'll show quickly because it's chronicling it, but it's pretty boring. I put in the tooltips, which has been a long time coming into the tutorials. We basically, if you haven't heard of it before, we wanted to make the tutorials as intuitive as possible without this text, just to kind of make people... First of all, it means that we don't need to worry about localization as much, because if it transcends words, then, somebody who doesn't speak the language can pick it up easily. But also, it's... a lot of people just don't read text, and won't ever read text. This is pretty obvious, but, you'd be surprised. So we need to cater for that. We also need to cater for people that, are just really tired after a long day's work and just want to kind of automatically feel their way through it. And finally, we want the mechanics in general to be as intuitive as possible, because when it comes to, if somebody's playing this game and they just pass it off to a friend, then that friend wants to be able to hear as little of an explanation of the mechanics as possible. They want to see the board and understand what's going on. So one thing that we did... Ooh, jeez. Oh, hold on. I'm not fucking recording in the... Oh, no, I am. In full size. Okay, cool. So I changed these indicators. So before, these were like diamonds on them, on the actual tile, and inside the diamond was the icon that you needed. We didn't want that, so instead we have this placeholder at the moment, but it's going to look like a socket, and we're supposed to drag that onto that. So yeah, that's pretty much a main change with the tutorials. We also changed up some of the levels later on, which I'll try to get to. This isn't too interesting to show into the actual code. It's mostly stuff that I've already done. One big thing is that I removed the timers on the monsters if they're not actually about to move. An issue that we found at the playtesting with this particular level is that if you're not actually paying attention, this monster will move, and then this message up top is meaningless. You won't know what the timer is, but I don't know. I don't think it's even that I don't even think that's a necessary level, because some people, even the people that didn't get that, they went on. And then there's this final level, and I kind of like this because it's a tutorial in the sense that it makes sure that you know all the mechanics, but it's also supposed to be kind of fun. So most people, they start from the top to the bottom, but if you're progressive, it's actually a bit easier to go from the bottom to the top. Some people didn't expect the tiles to kind of disappear like this. When they're disappearing up here, it's usually when there's no connection anymore. So if there's a tile here and then tile here, there's no way to that tile can ever be relevant, so it just gets rid of it. There's also an issue at the moment where essentially we're testing. We need to do this in the main game as well, but there needs to be a system where it detects whether or not you can possibly win or not. And an issue we have is that so the game... Oh, I actually messed it up. But if I do this, there's no way for us to win right now, because we need 3 plant in a row to kill that, but we can't get rid of this fire, because there's no water. So, basically planning on implementing some sort of a pathfinding algorithm. We have a system already in place, it's not working. I think it checks, if there's at least 3 or something. It definitely knows if there's none left. But we've got a reset button in case that happens. And yeah, that's all there is in the tutorial that got changed. Perhaps you are already familiar. But we now have some better UI. It's not terribly positioned well because this was kind of last minute. But now when you get points, then fire golem. Okay, thank you. Shows up there, shows up there, and that decimal point I had to make myself last minute. And that X is kind of off position, but yeah. So this doesn't look too interesting here, right? Well, if you like looking at code, boy, are you in for a treat, because this, I don't know if there's a easier way to do this, but basically, I have this class called a number string, which, as you might imagine, is a string with numbers, but I've just ascribed to it a font. And here's a first issue, is that I started off naming everything like score things, but then I realized the multiplier had to use it as well. So score char is just a number, basically. It may be worth renaming it, I don't know. But essentially we just have a sprite sheet of numbers.png, and it just, whenever it changes the value, I've got this function, which, it's not really interesting. It just basically, it's more of a thing with, it's more of a thing with ActionScript. So essentially, this is just like, basically we're returning bitmap data, which is kind of the information that we're getting from it, and it copies the pixels of a certain area of the source sprite sheet. So it just makes that, looks like a snapshot. Yeah, and then it's also got values like it can detect its own width, and it can detect like what width it should be, because annoyingly the sprite sheet, like each character is a different width. I think ordinarily they're all the same width, but I guess we didn't do that. So now we've got a different width for each character, and it's logged in here. And it's really not that much effort, and the sprite sheet's a bit smaller. So, and then they all squish together a whole lot more nicely. So these are our building blocks, but we need to know what we're using them for. So score value is something that is used on the right, and multi-value is a multiplier we're using on the left. As you can tell, score value is a bit simpler. I think, yeah. Both of these are extensions of number string. So score value doesn't do too much that's interesting. When we call this realign characters, which is just aligning its like X position, then it gives what the furthest to the right it is. I realize that the multiplier should probably actually be aligned to the left, but you know, who knows. Number string is where most of the magic happens. This update value is probably the most complicated part of the script. It's this big while loop, because I like writing while loops if I can. It's a nice brain teaser, and actually, even though it seems like it's really complicated, it tends to save time, because if you make like 2 or 3 pages of code, and then you're like, oh, I want to change this, then it's like difficult to go. Not only is it time consuming to change it all, but then you're introducing more and more potentials for it to be inconsistent. You know, when there was a bug where monsters couldn't move up, and that could have been solved with a good while loop, because it was like 4 if statements for each direction, like checking to see if they could move there, and one of the if statements was wrong, you know. So yeah, it's using so essentially we have our value. So let's look at this in a score, because this is the easiest way to begin explaining it. So we have, like, it'll be 10, 100, 1,000, whatever. We essentially have a separate char for each digit, and that's what we're concerned with. So the 0 part of the vector, or the array, it's a vector, or you can say array, that's going to be the first digit, and then 1's going to be the second, etc., etc. So it's easiest at this point to just straight away change value of the first digit to our value modular 10. I don't know what the word for that is, actually. Just the remainder of after dividing by 10. And so that'll chop off anything to the left of it. So, all digits to the left of what we're looking at, which is like 10 and above. So now we go into this kind of area. So we set our checking digit, which is the digit value that we're checking, that we want our value from, and I, as it usually stands for, is the amount of iterations that we've gone through this cycle. It's essentially how many chars do we characters, how many characters that we actually have in this string, and that's important here. I think it's also important here, but we'll get to that. So our var digit value, this line, what it's going to do is it's going to read what we should be saving. So I like this comment because it's poetic in a way. So as I mentioned, when you modulate something, maybe that's the term. When you modulate something, it essentially will cut off all the digits to the left. So the way I wrote this statement was I said, okay, I know this is correct. Let's deconstruct what's happening here. So we're checking the one digit, but we're getting 10. So that means that we want to multiply by whatever it is by 10, which makes sense because originally I was trying to use something with powers where, because each digit is like 10 to the power x plus 1, whatever. But this is the same thing. It is a form of power. So checking digit times 10, we know that value modulate that. We know that is going to get rid of anything to the left. It's just going to chop it off of what we want. And that fits into this bracket here, which fits into the floor. Wait, does it? Hold on. I thought it would. Where's this? Oh, yeah. Okay. So we've chopped off everything to the left. So if we had like 186 and we modulate it by 100, we'll have a remainder of 86. So we've got that. But the problem is because we're only looking after one digit, we want to get everything to the right of it as well. So what we do is we divide it by the digit that we are looking for, the checking digit, right here. That's as simple as it is. So in the previous example, our 86 would then go to 8.6. Now you can't have any decimal points in a single character, so we just math.floor to chop off all the rest. And that's pretty much how it works. Pretty elegant in that one line. I'm rather proud of it. So now we have to check. So we check our vector in its length, and if our iteration is equal to the length, then we need to add a new score char variable. It's basically we've now breached a point where we need to add a new digit. The way this works is that we always know we have 0 because we add it up here, which is in the constructor. But we don't add anything else until it's necessary because we don't want to take up space or memory or whatever. So when we go into this loop, none of this, this will immediately eject us out if we're below 10 and we're starting off. So we can basically look at this as soon as this becomes relevant, our vchar's length is going to be 1, and our iterations through it will be 1. Essentially, whenever our iteration is kind of the position that we'd be looking at, plus 1 for I plus 1 will equal, or is it? No, yeah, I will always equal what goes into this value right here. And because length is always 1 higher than the max value you can have here, you basically have to say, all right, if I would currently be inaccessible by 1, then we'd add that. I hope that made sense. It's basically all it's checking is that if we don't have a next score char prepared, add a new one. And then this is just making sure we add it to the sprite, so it's all got the same values and stuff. And then we change the value in here, which is again pretty simple. It just looks at the sprite sheet and draws the correct one. We increase our iterations, we multiply our checking digit by 10, and then we start the process over again until checking digit is finally above value, which is going to happen eventually, because first we check 10, then 100, then 1,000, etc. It's going to go above the value that we have. And then this checks if our current I is below vchars.length, because ordinarily, when we plus this, if we haven't breached a new digit, then this will always equal vchars.length. It shouldn't ever go above, but that's because of this. So if at the moment it's, oh, you know what? I think this will cause a bug if we add like 2 digits at once. That's interesting. I'm going to make a note of that and fix it later. This will cause an issue if we add 2 digits at once. Because this only, like, if vchars.length equals I think it, yeah, we'll have to make that a while loop or something. That'll only work if we've added 1 digit. Because if we add 2 digits, then this, would it though? No, I think that's fine. Because, like, if we run through this and we went from score 1 to 100 in one update value statement, then we'd go through this and we'd get the 10 value, and then I would equal vchars.length, so we'd push a new one, and then we'd go to the 100 and push another one. So yeah, no big deal. Anyways, this it goes to the removed digits. So splice is nice enough, is a ActionScript thing for vectors, nice enough to return the vector that was deleted. So we just want to make sure we go through the destructor, because we need to remove ourselves as a child of our parent sprite. Yeah, and then we align the characters, which is pretty much not much to talk about. It just takes the width that we have and then subtracts it from the score, the position to the right that we want. And then this is all basically counting up each of the widths and then changing the position of that particular character. A multiplier is not that that's how the score works. The multiplier, essentially, we are displaying a tenth of what mult value thinks it is, and then we're just putting in a decimal point. So all this code really does is that we have our decimal point, and we kind of cheekily put it into vchars, but we don't want it to ever change value, because it's a decimal point. By the way, these decimal points, they're going to take up 10 and 11 slots. Like symbols, they take up 10 and 11 slots. You can't ever get that on a single digit, you know? So it's kind of, it's better than going in negatives. For reasons that I can't remember. I guess you can take my word for it. Oh, I think it's, yeah, when you do this, something about that, I don't know. I made this a while ago, and I'm kind of tired, so I'm not going to go through it, and we're running out of time. Oh my god. So multi-value, it has this decimal point, and then basically it calculates the value as if the value was 10 times higher, because we'll be given like 4.5 or whatever, and so we want to multiply that by 10, so we get 45, and then we update it as if it was 45, and all we do is we just then try to find the very first element, which is the furthest to the right, and then we just want to put our decimal point in there, and then we reline the characters. And that's pretty much it. I think that pretty much covers it. So yeah, the user interface kind of bent pretty easily to that. It's just, instead of using text, we now use display objects, essentially. Yeah. I hope you enjoyed that. By the way, I feel like plugging, there's a game called Satellite Rain by 5 Live Studios, which just came out. It is a Brisbane-based studio. It looks gorgeous. I love that kind of stuff coming out in Brisbane. I highly recommend it as well. Funny that I'm plugging that more than my own channel. I haven't even begun to talk about subscribing or commenting and stuff like that. But oh gee, I think I'm about to run out of disk space. So okay, yeah. Thanks for watching. I'll see you later.